आज हम कुछ मज़ीद बेसिक टर्मिनोलॉजीज़ को स्टडी करेंगे जो कि इलेक्ट्रिकल की आगे मज़ीद जो इन डेप्थ एनालिसिस है उसके अंदर काम आएंगी। तो चलिए हम स्टार्ट करते हैं। सबसे पहले रेजिस्टेंस इज़ बेसिकली एज इट्स नेम सजेस्ट it is the opposition to flow of DC or AC current. It is valid for both DC as well as AC current. Its symbol is R and its unit is ohm. What is type of it? It is the real component of impedance. Normally impedance is categorized in AC analysis circuits. So there are two parts, one is real and one is the imaginary part. So this cater for the real component of the impedance. So if we talk about the dependence, resistance is inversely proportional to the area. If there will be the more area, then there will be the less resistance and more easily current will flow. And it is directly proportional to the length of a conductor. So if the length of conductor is large, then resistance will be more and the current flow will be slow. So it is defined by the Ohm law. It is the ratio between the voltage and the current, and it is analog to the tightness of pipeline. And if you want to visualize it, if there is a more tightness in the pipeline, then the very less water will flow. The resistance to the water will be more. So if you see in the diagram, you can see that there is a resistance. The current is flowing, but the resistance is trying to stop the current to flow. The next term is conductance, which is opposite to the resistance. It is ease with which current flows, and it also holds good for AC and the DC both circuits. Its symbol is G and the unit is Siemens or mho. That it is a real component of admittance. Admittance is opposite to the impedance in AC circuits. So it is, as it is opposite to the resistance, so it will be the inversely proportional to the length. If there will be the more length of the conductor, then the resistance will be more, then the conductance will be less. And it is directly proportional to the area. If the area will be more, then the better it is easy for the electrons to move and the current to flow. So their resistance will be less, so conductance will be more. So its formula is G is equal to 1 upon R, and it is normally used in parallel circuits and AC analysis. So it is visualized. If you want to visualize it, it is just like a wideness of pipe. So if the dia of the pipe is more, then the water will flow with more ease. So if you see in the diagram in the picture, that G is equal to 1 upon R, the unit of the resistance is ohm. So 1 upon ohm, when we take its inverse, it will become reverse to ohm, mho, and it is also called as Siemens. Unit is Siemens. So as we know that from the Ohm's law, V is equal to IR, and the I then become V upon R. So from here we can say that R is equal to V upon R. If we put if we know that G is equal to 1 upon R, then putting the value of R in place of V upon R, the G would be I upon V. As the R is V upon I, then the G will be I upon V. It is the inverse of resistance. Okay, now next there are some basic concepts regarding those are only applicable to the AC circuits. So it is opposition to the current only. Okay, the reactance is basically the opposition to the AC current only. It is not related to the DC. Its symbol is X and the unit is ohm. It is imaginary part of the impedance. Okay, what was the resistance? That was the real part, and it is the imaginary part, and it is it has two kinds. The reactance may be inductive, whose formula is XL. X is reactance, L denotes the inductive, and omega L. Omega is equal to 2 pi FL. From here, if you see that, if we talk about the DC circuits, there the frequency is 0. So XL will be 2 pi FL, putting the F frequency 0, XL is equal to 0. So for the DC circuits, XL will be 0. So these inductive reactance will not be applicable to the DC circuits. So the next and second is capacitive reactance, that is XC. X is reactance, C is capacitance, is equal to 1 upon omega L, and omega we all know that it is 1 upon omega C, not L. It is some error here. So 1 upon 2 pi FC. If we put F is equal to 0 for the DC circuits, the capacitance will become infinite. So these capacitive reactance and inductive reactance only applicable to the AC circuits, and they are dependent on frequency and the respective inductance and the capacitance. Next terminology is impedance. Impedance is total opposition to the AC flow. If you talk about the DC, there is only resistance R. But if we talk about the impedance, then the JX part, the imaginary part, will be added. And the JX we have studied, it's of two types. One is capacitance and one is inductance. So all three things, the resistance, capacitive reactance, and the inductive reactance, these all things will come under the definition of impedance. So AC version of resistance, but it includes reactance. So next is susceptance. It is imaginary part of admittance, and which is AC counterpart to the reactance. We just have read about reactance, so it is the counterpart to the reactance. Symbol is B, unit is Siemens, and the relation is B is equal to 1 upon X, as it is opposite to the reactance. So it is positive for the capacitors and negative for the inductors. So next and today's last term is admittance. It is the ease with which AC current flows. It is opposite to the impedance. The symbol is Y and the unit is Siemens. It is opposite to the impedance. Y is equal to 1 upon Z or 1 upon X. X or Z both are same. So its component is Y is equal to G plus JB. So G is what we have read in, that is conductance, and the B is susceptance. So if it is opposite to the impedance, so in the place of R, G comes here, as we know that G is reverse or opposite to the R, and B comes in place of X or Z. So these were today's some of basic concepts. We will see further definitions in next video. Thank you.